Okay, let's continue with 13, and then we'll look at our basic properties again. So 13 has log base 3, so if I have a base of 3, what exponent did I put on 3 to get an answer of 3 to the 11th? Well, once again, it seems obvious when you write it like that, right? X has got to be 11. But now there's another way to think about this. So here's our basic properties once again. These are the first 3 basic log properties that I think make a lot of sense if you think about because reason. Okay? The log of any base b of 1 equals 0 every time. And remember, that's because b to the 0 equals 1 for any base that's allowed. And remember, the bases allowed on logs are b has got to be positive and b cannot equal 1. Alright, now, the log base b of b always equals 1 because if I have a base of b, b to the 1 power, in fact, equals b. Notice all I'm doing is rewriting it in exponential form, and that makes much more sense to us. Okay, now let's try this third one, which is the one we just used on 13 without realizing it. If I have a base of b and I put an exponent of x on it, that equals b to the x. Well, duh, right? Okay, so that's what this property is. This is also one of the inverse properties. Remember, logs and exponentials are inverses of each other, and we talked about this in class. So one way to think about it is if you apply a log to an exponential and they have the same base, so we're assuming that they have the same base, then you just get back where you started. It undoes what's been done. So the example is, if I take the third root of x to the third power, what do I get? X, right? Okay? So that's what inverses do. Inverse example. The third root of x to the third power equals x, right? And it works the other way. If I have the third root of x and I raise it to the third power, then I just get back x. So no matter what order I do it in, I just get back x. Okay, now that is what these two properties right here are saying. I started with b to the x. Then I took a log base b of b to the x. b to the x is exponential. Log undoes exponential. So after I do everything, I'm just left with x. This one can make sense when we write the because over here. This one, however, is a little weirder. So you guys are just going to have to trust me on this. This time, I'm starting with a log base b of x, and I take that log and I put it in the exponential position there. Okay? But I put a log into an exponent, and they have the same base, and they undo each other. It's like taking a cube root and cubing it. So if they undo each other, I'm just left with x. And you can think about this and confuse yourself all kinds of ways, but just memorize it at this point and use it. Okay? So that brings us back to number 14. And instead of asking that why question now, we're going to try to use these properties. Are you ready? Okay. Log, remember this is our common log that we learned about that has base 10. So I'm going to rewrite it. This is the log, and instead of writing 1 over 10,000, I'm going to rewrite 1 over 10,000 as 10 to some power. 10 to, let's see, it's going to be negative 4, right? Okay. And now using those properties, this is log base 10 of something with a base of 10. They will undo each other and leave me with negative 4. Okay. Number 15, they just threw that 2 in front to spice things up. So let's ignore the 2 for a moment. So it's just, 2 is just coming along for the ride. It's 2 times whatever. Log, again this is base 10, of 10 to the 4.5. Well, the base 10 log and the base 10 exponential match, therefore they are inverses and undo each other, and I'm left with 4.5. So the answer here is 9. And then here's our natural log. Remember, natural log is base e. So if I have a log base e of e, what's the exponent on my e here? To the 1 power. Well, that's this basic property. Let's show it to you. That's this one. The bases match and there's no exponent, so it's just 1. That's just 1. Okay? So here's some more space so you can think about the basic properties some more. And now we're going to use that weird one, that last one we talked about. This time I have a base of 9 and I put a log in the exponent's position, and the log also has a base of 9. So I know they will undo each other and give me an answer of 10. Okay? 18. I have a base of 10 in the exponent's position. I put a log base 10. So they will undo each other and leave me with the 5th root of x. And last but certainly not least, I start with a base of e. In the exponent's position, I put a log with base e, and therefore they undo each other, and I'm left with 296. Okay. So there's some practice with log properties. 20 and 21, we did those in class, and you can do them on your own. They're very straightforward. It's mostly making sure you know how to use your calculator and find the log and natural log buttons on there. Okay, let's see if we can briefly talk about the domain of the log function. And remember, we also talked about this in class. The big deal is the domain of a log, or another way of saying this is you can only take logs of positive numbers. You can only take logs of positive numbers. Now I want you to be very careful. That means that the thing I'm taking the log of, in parentheses, x minus 9, has to be positive. So the way I find the domain is I go x minus 9 has to be greater than 0, and I solve that equation. So in this case that would be very easy, and in interval notation we would get 9 to infinity. Okay? Clearly I skipped some steps. Remember, 23 was kind of just a thinking question, and we talked about it in class. We'll do that. And 24, remember, this is going to be on the final. I guarantee you a problem like this is on the final. Because we look at the log, we are asked to find the domain of this log function, and so we say, okay, I know that the thing I'm taking the log of, which is the polynomial in parentheses, has to be greater than 0 or positive. And now I have a quadratic inequality to solve, and we learned how to solve those in Chapter 3. So that's why it's on the final. It's Chapter 4 and Chapter 3 stuff. And remember, to do that, we factor completely. Well, first we get 0 on one side, which is done. Then we factor completely. Then we make a number line, and we find our zeros, what x values would make this polynomial equal 0. This is a strictly greater than, so I know I'll have open dots at both places. And then I either test or visualize the graph to figure out which intervals are positive and which intervals are negative. And when I visualize this graph, I know it goes positive, negative, positive, like that. And which pieces do we want? The positive pieces. So the domain of this function is negative infinity to 8 union 9 to infinity. Okay? Alright, now the graphs of logs, which is what the rest of the handout is about. We talked about that in class, and if you have any questions about graphing logs, please ask me in class.